Hey, hey, hey. How's everybody doing? What would you what would I predict to be the hardest parts of the project? Oof. Uh mm, because I think I'm done with the first four to-dos and might be feeling overconfident with the wife and kids. No wife, no kids, just the cat. I think filter sort paginate is not a lot of lines to write, but pretty maybe a little bit dense. So maybe that, and then probably the get students and get grades, the ones that are supposed to list and sort and filter and paginate and all that stuff return. The endpoints that use filter, sort, paginate probably would be the next two hardest ones. No problem. No wife, no kids, Sag. Is Sag the new hip way of saying that sounds sad? I don't even know anymore. Okay. Google Sag. Oh, it's the froggy frog. Okay. Yeah. I gotcha. I didn't know that's what that guy was called. Carry on. How's y'all's week? Oh, that's some ASCII art. Damn.
So I don't know what's going on, but all I see is sad Pepe.
Yeah. Yeah. Uh huh. I loved the Thorn trilogy. Oh my god. But it's probably been like 20 years. But yeah, it's such a good series. That is the canon version. The EU is the extended universe canon. I mean, it's not canon anymore since they like redid the whole thing since Disney bought it. What did they rewrite the Thorn? What is it? Thorn trilogies? They rewrote them. So they rewrote it after Disney bought it and threw away the whole extended universe. Oh, well, I really did like that author. That's true. Got to milk Star Wars for all it's worth. Yeah, yeah. Actually, just finished the most recent Dresden Files book, and holy shit, that was a good book. And yeah, Mara needs to be canon. Imagine reading anything but code. That's true. Timothy Zahn was a good, or is, I don't know, is he still around? He's a really good author. I read some of his other stuff, I think. Um, there's something about like starfighters and alien lizards. I don't remember. If I could read code instead of boring textbook, I might do the reading for more of my classes. Yeah, true. Which alien movie is this? Flat Stanley. No, I did not. Can't say I read that one. Speaking of alien movies, I'm watching Raised by Wolves right now, which is not quite aliens, but also definitely Ridley Scott and pretty damn awesome. I don't even know what you're saying anymore, Nathan. Y'all crazy. All right, let me get this shared screen thingy up and running. Chat just stops. I know. Everybody stops and it's like, okay, well, if we can't include Nathan, then I guess we should all just stop talking then. What is the opposite of a catalyst? Like the buffer agent or something? Inhibitor. Ah, yeah, that's probably more true. The repellent side of the magnet. Okay. All right. Proteins that binds the enzyme blocks the. Yep. Okay. So, yeah, not yesterday. Monday, we had written this whole thing. And we got the search working, which I know I was as surprised as you all were that it actually worked correctly. But it worked. So that was cool. Um, Anybody have a chance to think up more questions about this or read over it or want me to go back over anything before I talk about maybe creating stuff?
Can you give the gist again, just as a refresher?
Yeah. So
Cool.
here's all
Thanks.
our boilerplate at the top. Same thing as what's in our file. Don't need the Bluebird stuff anymore. Apparently, Node.js has a built-in function to do that, but we're doing it the old school way because I didn't want to change my code. We have this get PC function that returns a promise, and we have a search for function that returns a promise. And get PC first tries to get all of the keys and values out of a hash called PC colon whatever ID you pass in. So PC colon 1 or PC colon 2. And that looks, nope, not like that. This one? Nope. Where'd it go? Ah, looks like this one. Okay. So here's kind of what our PC hash looks like. I think we also tried to make a PC2 or something. I don't know if that worked. I can't remember at this point if we actually added in a second PC. But you pass the ID in. So the key inside Redis that all this stuff is stored under is PC colon 1. And so inside that top level Redis key, there's a hash. And we're trying to get all the keys and values out of that hash. And we want to do it in such a way as to use a promise when it comes back instead of giving a callback. So that's hence the async. This is handling the object we get back out of the database. These are all the key value pairs that are stored inside the hash that is stored inside PC:1. Confused yet? Good. Then we pull out the RAM, CPU, and motherboard out of that hash and leave the other two things, which are name and something else, and leave those as a final PC object. So that gives us two objects, one that's got, we got our initial PC object from the database, our final PC object that we actually populate with the RAM and the motherboard and the CPU and all that stuff down here. And then we pull out the IDs for the RAM, CPU, and motherboard here. We do hgetAlls, same sort of thing as we do up here, to find the RAM based on the ID that was in here, that was in the PC object. Same thing for CPU and same thing for motherboard. We add all of the promises that these return. So each one of these client calls returns a promise. And instead of saving it into a variable, we just immediately push it into our array of promises. And then we do promises.all so that we can wait for all of these things to finish, since it's going to send all three of these out in parallel to the database, wait for them all to come back and be processed, and then we return the final PC object from inside this .then. So this return returns the promise. The .then is part of that promise that gets returned here. And inside of a .then, instead of returning a value, we can return another promise, which is what we do here. And we aren't just returning this promise, we're returning this promise with an extra .then on it, because promise.all does not actually pass in any arguments to your .then. It's just like, hey, I finished everything. And you're like, well, what was the result? And it's like, the result of which one, bro? Like, you just ran three things. Which one do you even want? So since it doesn't know, it doesn't give us anything. So we have to actually attach this extra .then on there to return final PC object, so that the .then we use here actually gets that PC object. Kind of do the same thing for search, except we're looking through the members, or the members inside the set. So what is this? This is for the set of RAM or whatever. So there's a set called RAM, and inside of it, there's like 1, 2, 3, however many IDs we have. And so we just loop through all of the things that are in this set, and we look for each, we try to get each hash. So this would be like RAM:1, RAM:2, whatever's in the set that's named RAM. That's what we're looping through here. We do the promises.push fanciness, and we do this, the same sort of return promises.all.then, except here we filter it a little bit before we return it. So this part does the filter. This part sets up the filter. This part executes the filter, generates this new filtered results array of RAM or whatever we've actually filtered out, and we return that, and that's what comes back here. And then we client.quit just so it doesn't hang up in Node.js.
Cool.
Any questions?
When does that there was a first like array or whatever at, I was like maybe Monday or last Wednesday. Yeah, I think it's in the Redis DB file where it has like the PC1, PC2, like all the names for the different keys that you have in there.
Yeah.
When does that come into play? I guess
This I just ran these commands directly on the Redis CLI.
No, like the I guess the array that holds everything, like all the top level keys.
Yeah. Where did I write that? I don't know if, I think I actually wrote it directly in the CLI, but you're talking about adding stuff to the set of all the RAM?
Maybe.
Let's go over here and we can do Redis CLI, and we can do, what is it? S members. So last time I think we did S add, right? Is that what you're talking about? where we added 1 and 2 to the set called RAM, and 1 and 2 to the set called CPU. And if we go look at it, S members RAM, it'll tell me that that is a set, and it's got 2 things in it, 2 unique values inside of it. And so doing that is what we're doing here with this S members async call. So we're actually saying, hey, give me, and this type. So when we call search for down here, the first parameter is RAM. And so that becomes type. So this is just the string RAM. So we're saying, hey, get me all the members of the set that is stored in the key called RAM. And we could change this to CPU or motherboard or any other string. And if we did any other string beside those 3, I think it would probably error, and we'd have some really interesting things that we'd need to catch or debug or something to keep it from crashing. But yeah, that's that set.
Gotcha. Cool. Thank you.
If the Redis query doesn't find any matches, does it return an empty array, or does it have a special response error? It depends on what your query is. I think it most of the time will just, like for S members here or for hgetall, since they're actually trying to get like not only something that exists, but something that exists and points to a specific data type in Redis. Like this points not only to that like PC:1 exists, but also expects PC:1 to be a hash. I think if either of those are false, your answer here would be false maybe, or you might have a dot catch down here. We could test that real quick. Let's go over to this. Let's just go into our index.js, and instead of searching for RAM, let's search for RAM ASDF, and let's see what that does. Well, it didn't throw an error. It just said results are blank. And what did we do? Let's see. If it didn't return anything, this would actually give us an array of IDs. So apparently it gave us an empty array. And then down here we say results are this, and this is these results that we created here. So I bet you this was just an empty array. And so it didn't run through this for loop at all. So results continued to be an empty array. So that's what happened there. Yeah. Now it might be different, might be an empty object for hgetall. And there are ways to check if something exists first, like h_exists or something like that. Or just exists as a top level key, like, hey, I don't care what this data type is. I just want to know if the key exists and points to anything at all. So we could do that, but for the most part, you kind of expect that exists. And maybe you should like check, maybe I should be checking inside the search for function to be like, okay, you can only search for these types right now. If it's anything else, I should throw an error before even talking to the database. That would be cheaper than doing a database exists kind of lookup before we do all this other stuff. But we could do it. Wouldn't be too hard. Okay. So I think so I added all of these things by hand last time, but what if we wanted to create a new RAM stick, for example? So I'm just going to make a, let's see, const create RAM. I'm just going to make this one specifically for RAM, but you guys, I mean, it could probably be generalized if you pass in a type to say what you're trying to create. But certain things like, let's say create component, because the PC doesn't have a set, but all the components do. CPU and motherboard and RAM all have sets. So let's just try a create component thing. I'm not going to create PCs because that seems just kind of easy. So this will take in a type, and it'll take in some like component, and that'll be an object. So let's call it component object so it doesn't confuse people too much. So now the first thing we need to do is like s add, right? So let's do like return client dot s add async. And we want to add to the type. So this is like RAM or CPU or motherboard. So we're adding to that set, and we're going to add the value. So the problem is the way we did this, we just gave IDs to each RAM thing. So I'm going to say, I'm going to hard code in an ID. This is why the counter way of doing things works better. Or putting an ID on each one, we kind of like munged up those two strategies. So if we go look at our console again, our RAM doesn't have an ID. Like this could conceivably have some random ID that's like a name, or like, you know, this is the Kingston awesome brand or whatever. And that could be the ID. And then we would have all of the IDs in a set. That would work well. Because if that ID, that long string name or whatever actually already existed in the set, we wouldn't be able to add another one. We wouldn't be able to overwrite this. So that would work. And then it would actually be stored in RAM : awesome Kingston, you know, RAM stick or whatever. So that's how we're doing stuff like students. Students have like a username. And so we put all the usernames in a set, blah, 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 blah. The way we do grades is we just keep a counter. We don't keep a set. Because all grades are so generic, we're just like, I don't want to come up with an actual ID, unique ID for each grade, because it could be the exact same grade from multiple users or something like that. So like coming up with the logic for all that, it's so much easier to just kind of auto increment a counter. And then we don't need the set. We just grab the counter and we loop through and try and get everything from 0 to whatever the counter is out of the database. The way we're doing our code here is kind of like we're using IDs that are numbers, so we shouldn't be using a set to store them all. We should be using a counter. But we're just going to kind of gloss over that, and we're going to take in an ID attribute or an ID parameter here. So when I call it, I want to be able to call like create component, and I want to say, I want to create a RAM stick. I want to give it ID 3. And by the way, this doesn't have to be a string. It could just be the number 3. It'll get converted into a string somewhere along the line. Most likely when it gets added to the set, I think. But we'll just leave it a string for now. And then our component object, this is the thing we actually want to store into it. So this might be something like capacity 32 gigs, slots for, what else did we have? Speed. No, I'll just leave that as a number, whatever. Okay, so this is eventually what we want to call. Ignore that this is kind of a dumb way of doing the ID because we have to actually know what ID. I mean, I guess we could pick like any random thing and it would always work the same way. So we could make that our ID if we really wanted to. Yeah, may as well, right? Okay, just because we have a 1 and 2 doesn't mean we have to have a 3. All right, so this is going to do sadd, and we're going to add the ID to the set. So we're going to try and add this thing to the RAM set. And the fun thing about sets is it will tell us whether we were allowed to add that or not. So if we go back over here, we go back, nope, not into that. We go back into our Redis CLI and we do S members RAM. What is it? S members RAM. And so we get those two things. If I do sadd 1, sadd RAM 1, it says integer 0. It gives us back a 0. And if I say sadd RAM 3, it says, yeah, sure, you get a 1 back. And if I say sadd RAM 3 again, it says no, and you get a 0 back. So what that 0 is telling you is how many things were actually added to the set. It's not going to add it to the set if it's already in there. How do I remove stuff? Yeah, RAM 3. Just to check to see I put it back. Okay, so sadd will give you a 0. You can add multiple things at once. So let's say you added 3 things and only one of them was newly unique to the set. I think your counter would actually be, let's say you added 3, 1 was unique, so your counter would be 1. If none of them were unique, they all exist in the set, your counter is going to be 0. So we don't have to check to see if the thing exists, if this ID exists in this set before we try and add it to the set. We can just add it to the set and then say result, because this is going to be our 1 or 0. If result is greater than 0, I think it's going to be an integer. Let's just console.log result. Let's see what this does. I think that's good enough to work. Okay, so let's Control C out of this, and let me copy it into our terminal thingy we have over here. Okay, that's, yeah, all right, wrong page. Let's put the create component in there. Okay, yeah, right. Now we can paste. Then we want to delete that line, and we want to call create component dot then. By the way, I need to write this little extra code client dot quit. I'll switch back. I'm not switching back for this. I'll just paste in what I just wrote. Okay, so down here we have our create component, and I moved our client.quit down to the bottom here. So here's what we're creating with the ID and all that stuff. Let's see what happens. Oh wait, did I? I did not. Let me fix this RAM thing. Okay, now we can run it. So we got a 1 back. And if we run it again, cannot read property slots of null. That's it, filter line 31. So let's look and see. I know exactly what I did. I added it to the set. So when we do the search for thing, where is, did it say 31? Oh, line 70, character 31. Okay. So if we go line 70, this thing, this filter function's not going to work because it's actually going through and it's trying to get all of these, you know, RAM 1, RAM 2, and now RAM 3, because RAM 3 is in the set, right? Or RAM, whatever the key was that we created, was in the set. And so it tries to get it, and it gets some results. And that result is apparently null because we push null onto this thing here. And then inside here, we try to access null sub key, and that's where we broke it. So let's go back to our database. srem ram, or let's do s members ram, and then srem ram 243 frw3. Didn't make that very easy to type. Okay, did I type? You know, maybe I should probably just paste it. There we go. There we go. All right, now we're back to normal. So we did learn that up here, it gives us a 0 the second time and a 1 the first time, and it's just the integer. They don't wrap it in a string for us. So now we know how we want to write the rest of this code. So result is 0 or 1. And now we can do something like if result is greater than 0. And so because this actually got added to the set, that means that the hash for RAM : whatever also does not exist, and we have to make it. Conversely, if it did not add this to the set, that means it already existed, which means RAM : ID also existed, and we don't want to overwrite it. Else do nothing. We don't want to overwrite the hash. So this is the ID was added to the set. The ID was already in the set. Okay. So since it was added to the set, we have to do a client, let's see, return client dot h, oh, what did we do over here? HM set, okay. Set async, always with the async. And we're going, the key is going to be, it's going to be type, right? Colon ID, awesome. And by the way this works, we actually would be perfectly fine even if the ID had a colon in it, because we're putting our first colon in there first, if that makes sense. And we're never splitting on colons and grabbing the first thing and the last thing. Ooh, that's not what I meant to hit. Why did that window open? Okay, so colon, I mean, the ID can pretty much be anything because it's all binary safe. When we go through S members later, we're going to get that ID back, and we just stick type colon at the front of it. And yeah, so we don't have to worry about like preventing escape characters and stuff like that like we normally do on other databases. Okay, so we want to set this as a hash, and what do we want to set into that hash? We want to set our component object. And there really isn't a reason to .then unless we want to catch an error, but let's fly by the seat of our pants. So let's just return that. And otherwise down here, we can just say return true, I guess. I guess we don't really need to return anything, but yeah, we'll see what happens without it. Okay, so we got this. And inside this .then, let's do another search. And this, what do we add? What are we adding here? We're adding something with 4 slots. So if we do another one of these searches inside here, let's say, just to break things up, console.log, added RAM, doing another search. All right. And we're going to search for 4 slots this time, see if we get 2 results back. Ooh, fancy. Okay. I think this will work. I think it'll work. We aren't really looking for anything in our .then, so it doesn't really matter what we return here. Yeah. Okay. Let's just copy all this and put it into our thingy. Nope, not that thingy. See if this works first time. Ooh. HGet all can't be processed. The connection is already closed. What? Huh? When did I close the connection? Oh, because I did it here. Yeah, this client.quit needs to be in here, doesn't it? Yeah. Mm-hmm. Mm-hmm. All right. Now we got to clean up some stuff. Yeah, I know, right? The trials and tribulations of writing it. Of fuck it, we'll do it live. Redis, CLI, what SRAM, RAM, this thing, and what is it? What is it? RAM. How do you? Oh, delete. RAM colon that. Okay. I think that's all cleaned up. And let's go fix this thing. And let's give it another shot. Hey, I'm sorry, Max. Don't hate me. Don't report me. Funny thing, it says adding RAM doing another search way up here. Why does it say it way up there? But here's our actual RAM stick being returned. Awesome. And I bet you if we run it again, it won't error because we have that else no op in there. Yay! All right. Now, why is this at the top though? Because adding RAM doing another search, did that really come back before all the other searches did? Let's go up here. Let's go look. So this was a first search. This was that search for that we ran before we did create component. That's the RAM results. And out of order from that, before we, okay, so these are the PC results. Oh, and this is the actual returned RAM results. This is just saying what the results were to prove that we were not modifying the array. Okay. All right. Well, maybe I should comment out some of this stuff. Okay. So anyway, that's how we do creating. That's how we do the creation stuff, at least for a set. Remember, you don't have to check to see if it exists first. You can just add it and then check your results afterwards and move along. So deleting it, modifying it, all that stuff is pretty simple. You know what, I showed how to do a delete on the Redis command line. It's just, all right, if you want to delete something, you have to remove it from the set, and then you also have to delete the top level key for RAM colon whatever the ID was, or type colon whatever the ID was. Yeah, so you have to delete those two things to make sure it's gone. If you only delete the second thing, but you don't delete it out of the set, then we get that error here, right? We get that, hey, this thing didn't work right. And it was in the set, but I couldn't find the actual key for it, and I just kept trucking anyway and ran into a null object exception or whatever. So when you delete stuff, do it that way. When you modify stuff, you don't even have to do the sadd. You're pretty much just doing an HM set. Any questions? Just one. Okay. Nope. 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 Oh, God, that's painful. Okay. All right. So last night, and this is like the one thing I got bored last night and tried to prove to myself that you shouldn't do stuff a certain way. So I tried to prove to myself that you shouldn't do things in like a 3-line where you dot then and then you push the promise here on, because I figured that this, if you're not chaining all this stuff together like we do here, you know, and here we actually just chain all of our stuff together. The thing that we push into promises is not the promise that's returned from this. It's the promise that's returned from running that and then doing the dot then on it, which is, by the documentation, it's a different promise. So one would think if you do it the wrong way, and so I have this, like, I have a thenner and I have a dunner and I have a waiter, and yeah, it was like 10 o'clock at night last night when I was writing this code because I was like curious and bored and watching Raised by Wolves and Looper. So yeah, my name's kind of got, don't worry about it. But I assume if you do a dot then and then you push the original promise onto the array that you're promise.alling on, that you should get something like, you know, let's say this does some work inside your dot then, this thing right here. It does some work, it loops to like 5,000, and then it sets the object of whatever key to a counter, which will be like 5,000. And then inside here, if it's still false, then it's going to throw this error and it's going to break because this like promise.all thing actually happened before all of the dot then things completed doing what they were doing, which is kind of what you would think this code would do. But I ran this code for like 45,000 loops and it never errored. So I learned that this probably isn't a terrible thing. I mean, it's terrible in that, like, it makes it harder to read than if you were to just like composite stuff together in this sort of like easily readable, like you're doing this and then you're doing this and then you're doing this and then you're putting the whole of that result into the promises and everything's hunky-dory. Over here, it's like, hey, you have this promise and then you add a dot then to it and then you maybe do some other stuff and then you push it onto promises. You could probably, it's I don't know. For me, it's much more readable to wrap this whole thing, waiter, you know, to do something instead like promises dot push waiter of object dot then. Let's just grab all that. Yeah, I think, and especially, well, okay, so maybe that's not easier to read, but that's a little bit easier to read. And I guess I haven't talked too much about bind. Have I talked about bind and how you can, not much easier? Okay, all right, fine. Have I talked about using bind to pass in extra variables? I think I have, right? So then this thing right here takes in the key and the object. But when our waiter actually returns stuff, it's just resolving with the object. So remember, like when you call resolve, whatever you pass into resolve goes in as the variable, or it goes in as the parameter for your dot then. So this thing is only getting one parameter as when it's dot then. Like waiter is only adding one parameter into this thenner function call. We add the other parameter, that key parameter, by doing a bind. And this is the closure stuff we talked about earlier in the class, where we're like, this dot bind creates a new function pointer that has a closure inside of it. And in that closure, it creates it has this extra variable and it passes it in as the first parameter. And then, so whenever this gets called here, whenever this whole thing, whenever dot then calls, it's going to call something and pass in one object, and then inside the closure, it's also passing in this other parameter. So this is like, hey, make me another function pointer that has the first parameter always set to this thing, to this string that I'm making right here. Don't worry about this null. That's just trying to set scope. Remember, for fat arrow notation functions, we can't set scope, so you could pass like, you know, 1 or like empty quotes or null or false or even an object. It doesn't really matter. I just like null. I don't know. But I'm like, hey, I'm sending you a string. I want you to make me a new function who, no matter how it gets called, the first argument will be this string. And you can do that with multiple arguments. I could have a second one here that's like the object or like I or whatever. And it'll be like, all right, I want you to make a new function where every time it's called, these three things are its first three arguments. So this is a nice way to, like, when you get an object back from a database and you're looping through stuff and you want to know what request actually sent that object off, or what request you sent off got you that object back, you have a general purpose handler for your database responses, and then you just bind it so that you know, like, oh, I was trying to get RAM number 1 or RAM number 2 or RAM number 3. Does that kind of make sense? This is kind of a tangent anyway, so I guess it doesn't matter too much. Don't worry, it's not going to be on the quiz. Speaking of, when did I set the password for the quiz today? Anybody have any questions? I'm kind of running out of stuff to talk about today. Mega green. Is it? I don't think I set it to that. Today's the 28th, right? Big yellow. Nope. Sag. If nobody has any more questions, the access code is actually just, okay, that's not the right one. Red. R-E-D, all capitalized. No spaces at the front, no spaces at the back. Y'all are getting out early today. Enjoy your free 30 minutes. Hit me up on Slack if you're running into any problems, and I'll be around. Reasonable length. Last question is kind of hard. Well, you know, I have to throw at least one question in there so that somebody can screw it up while they're playing WoW in the background or something. What was the password? R-E-D, all capitals. The color, the word, the experience, red. I don't know. What, you want me to say, like the Taylor Swift album? Like, come on. I'm just making stuff up here. Okay. Good luck on the quiz. I'm out. I'll see y'all on Slack if you have any more questions. Have a great afternoon.